Good morning and welcome to our second Build Up webinar organized by the Smart Build for EU project. My name is Karine Lafont-Elloire. I work for Dowell Innovation, a partner of Smart Build for EU, and I will be moderating this webinar. Today, we welcome 7 EU-funded projects, all related to smart buildings, but all with very different focuses and state of progress. They will have a few minutes to present you their project, which is a challenging exercise, but we'll have some time at the end of the session to answer the questions you may have. Before we start, I will shortly introduce Build Up. Build Up is a European collaborative platform. It's always updated and it's a key resource on the topic of energy efficiency in buildings. You can register and become a member of Build Up community to then submit content as news, events, publication cases, and so on. We invite you to navigate the portal. You will be able to find the podcast to the past webinars, and at the end of this webinar, the recording and the whole presentation in PDF will be available in the portal. Today's webinar is the third webinar with this format, and 25 projects have joined us in this journey so far. The aim of these webinars is to share good practices and lessons learned with the community of projects, and beyond that, with the whole smart building innovation community. The results and innovation presented will also be key inputs to the work of the task forces that have been launched by the project Smart Build for EU. I now would like to welcome our panelists. So they are listed here. They will present 7 very interesting projects which cover a variety of topics: energy efficient renovation and technologies, energy performance certificates, big data, digital twins, training, and much more. We'll start with the projects that are close to completion, which will highlight their lessons learned, and then we'll move on to the projects that recently started. We have selected this project because they are very relevant to the work we'll launch in the coming month with our task force. This task force and their new topic being investigated are written here, but I won't say much more on these ones because Nerea Gomez, our project coordinator, will now quickly present Smart Build for EU and its latest progress. Nerea, the floor is yours.
Thank you very much, Corinne, and good morning, everybody. Thank you very much for joining this session. My name is Nerea Gomez from ECTP, the European Construction Technology Platform, and I will briefly introduce the project Smart Build for EU, which will serve the basis of what we want to achieve during this webinar. Oh, sorry. In a few words, Smart Build for EU started in October 2020 under the topic Support to the Coordination of European Smart Buildings Innovation Community. The idea is supporting the challenges of the smart buildings. Regarding the consortium, the project is led by ECTP, and then it is Dowell Innovation and R2M, both in France, Europe Research in Italy, and Vito in Belgium. We are also surrounded by 5 linked third parties: ASM, Cardiff University, LIS, TNO, and VTT. They are all bringing their expertise and the coverage of Europe, in order to bring as many stakeholders as possible in this project. Now you can see the main activities of the project. The first activity is mapping and consolidation of the Smart Building Innovation Community, the SBIC as we used to call it. The objective is to promote key innovators and innovations in smart buildings, bring people together, involve them in activities, and start making them exchanging. Based on that, the second activity is knowledge sharing and supporting activities for the SBIC, bringing interested stakeholders around the table and make them work on the challenges of the smart buildings. We have organized task forces, workshops in order to produce white papers addressing those challenges and proposing recommendations of solutions to progress on the smart building sector. The third activity is more technical: contribution to the promotion, experimentation, and rollout of the SRI as the base for the smart buildings business case. The SRI, the Smart Readiness Indicator, that you probably already know, that is the common European scheme for rating the smart readiness of buildings. We want to start on and go even beyond in order to list a certain number of co-benefits that, in addition to the SRI smart technologies products, can bring to the buildings, concerning as well the energy efficiency, comfort, and health of the occupants. And finally, all these inputs will serve to provide a research and innovation roadmap, again addressing the challenges already mentioned before, providing policy recommendations, and directed to both member states and the European Commission. And of course, certain number of communication and dissemination activities in order to promote our work and enhance the visibility of the SBIC. A few examples of promotion activities beyond today's workshop, where you actually will hear different presentations of several European projects that are relevant in the sector of smart buildings. You can see some project and technology brochures promoting several smart building projects and their outcomes, which you can find all of them on our website. Moving on to task forces, we have defined 4 task forces: interaction with users, efficient building operation, interaction with the external environment, and cross-cutting issues. They are a group of experts that meet during a semester to discuss about barriers and drivers, research, and gaps. Then there is an open consultation, and finally the results are consolidated into a final white paper, which will fit the research and innovation roadmap. This is an example of the last topic addressed during the last semester. All the white papers are available online and you can find it on our website. In May, we are launching the next and last topics, which you can see on the slide. So I also take the opportunity to invite you all to participate on our next workshop, which will take place on the 5th of May, where we will launch the final topics. If you are also interested in participating to the task forces, it is always possible to join us, and all information is available on the website. Regarding the contribution to this promotion of the SRI, we are working to better understand the SRI function and address the lack of clarity in the marketplace about the benefits for the smart services. We have identified the main co-benefits indicators associated to smart buildings, and now we are developing technology solution packages for this smart building. So we are assessing them in terms of co-benefits and SRI, trying to demonstrate the added value of implementing smart technologies in buildings. All these findings will be used for training materials and workshops that we are organizing at national level. For example, on April 1st, took place the first national awareness workshop in France, which was organized by R2M. Then the research and innovation roadmap, whose aim is to support the European Commission and member states in gaining a better understanding of the state of play of the SBIC needs and identify and tailor key priorities for the European support to research, innovation, and market uptake in smart buildings. The idea is to increase the implementation of potential and chances for success of the priority actions that have been identified. To conclude, I invite you all to join our Smart Building Innovation community if you haven't done it yet. And also you can find us in LinkedIn, Twitter, and now on YouTube. Thank you very much for your attention.
Many thanks, Nerea. Before I give the floor to our speakers, I would like to apologize in advance for any name I may mispronounce with my terrible French accent. But now I would like to ask Irene Barbero from Cardiff University to present Instruct. So Irene, the floor is yours.
Yes, thank you very much, Corinne. Good afternoon, everyone. Thank you for being here. So my name is Irene Barbero from Cardiff University, and I will be speaking on behalf of the Instruct project and our European partners. So just a bit of generals about the Instruct project. It's a project that started in June 2020, and it's still ongoing, and it will be completed in November 2022. Here you can see in the slide our website that you can consult, and the thematics at the right part of your screen that we're looking to address. So what are the project objectives? we have several objectives. So the first one is to elicit quantitative and qualitative evidences that corroborate and reinforce the correlation between skills and education and energy performance and quality. Secondly is to pave the way to a set of tools and instruments facilitating the mutual recognition of energy skills and qualifications in the construction sector. Then to carry out real-world demonstrations in 5 geographical European areas of the usefulness and ease of use of the deployed instruments for recognition of energy skills and qualifications. Fourthly, to deliver dissemination and awareness raising actions in consortium members countries scaled up to the wider Europe. And lastly, to pave the way to new legislative frameworks, enabling reliance on skilled workers in public and also private procurement. Now, some of the issues and the challenges that we have been addressing, and here I'm referencing also the barriers that have been highlighted by previous project Build Up Skills. We're looking to address economic barriers. So, for example, industry operating with tight financial margins, resulting in lack of time for and investment in training. Legal barriers, which include lack of an EU-wide legislative framework, stimulating the demand for energy-skilled construction workers and professionals. Market barriers, so low demand, recognition and certification measures of skills for energy efficiency. And also knowledge barriers, so lack of support for experience and best practice sharing across the industry. So, apologies. Yes. So some of the key results that we're presenting here is a one-stop shop platform which is found on www.energy-education.com for training in the construction industry, powered by blockchain technology. And you can see a screenshot of the platform in the top right of your screen. The platform involves an ensemble of services which include course certification for training providers supported by clear learning outcomes, passports, registers for workers recognized at EU level, certifying their qualifications, skills, and training portfolio, awareness raising of new legislative frameworks or public procurement practices, promoting and disseminating initiatives for home and building owners, and lastly, promoting new partnerships with producers and retailers. And you can see at the bottom, right bottom of your screen, an example of mobile application that we are currently developing using blockchain via our platform. So what is our unique value proposition? It's a trusted platform which provides easy and structured access to adapted and up-to-date training in energy efficiency aimed at the entire supply chain and across the whole life cycle, with the potential to assist the European Union to achieve its energy and carbon reduction targets. The market and audience that is being targeted, we're targeting the training market across the entire spectrum, life cycle and supply chains of the construction sector. So as such, the market audience is the construction value chain, including community of users, stakeholders, i.e. design practices, engineering organizations, contractors, facility managers, as well as training providers, training organizations, trade organizations, and more. So our approach, the approach that has been implemented by the project and the demonstrations that have been carried out. So at the top left of your screen, you can see our methodology. So we've been following mixed methods approach based on a pragmatic philosophical theoretical framework. So we're combining both quantitative and qualitative methods and some consultation tools. So we've been using questionnaires, interviews, use cases, or workshops to elicit data. And on your on the right part of your screen, you can see the demos that are currently ongoing and are developing in 5 European clusters, as you can see, and you can also see there the different aims, but also the partners that are involved in each one of them. Lastly, at the right bottom of your screen, you can see the architecture that is proposed in terms of the blockchain technology for our platform, a diagram for that. Now, our achievements up to date is a TRL 7 one-stop shop training platform with the potential to be scaled to TRL 8 by the end of the project. And to conclude, some lessons learned. First of all is understanding training needs to adapt to an evolving and dynamic landscape characterized by continuous technology evolution and the need for adapted and tailored training for the construction workforce. Also, the need to continuously update course offerings to adapt to the dynamic nature of training and technology business processes evolution. And lastly, no size-fits-all approach, so the need to provide adapted and continuous training to users based on the profile, i.e. qualifications, skills, and work requirements. And some good practices, our platform, which I mentioned previously, could be used as a vehicle for knowledge, experience, and best practice sharing within organizations across projects and beyond in the construction industry. So that's all from me. Thank you very much for listening.
That's great. Many thanks, Irene. And Edward Loskos from IDP will now present Sphere.
Hello, thank you so much. I will explain, trying to do the overarching objectives. Sphere is a 4 years Horizon 2020 projects. So far, we were the first European project focusing or talking about building digital twins, or how the digital twins could be impacting into the construction sector. So at the end, the main objective was to provide this BIM-based, obviously a digital twin in the construction sector should be using an information model under the BIM methodology. Okay, so a BIM-based digital twin platform to optimize the building life cycle. Okay, at the end, something that I think it's easy often forget is that a digital twin should be a product lifecycle management. Okay, or that's the origin, okay, of the digital twins, and how the digital twin environment could help to ease the transition of the information among and in between each step across or along the life cycle is crucial. Okay, so this is why we propose this methodology. So a BIM-based digital twin platform to optimize the building life cycle, obviously reducing the costs. If not, no one is going to do this effort in terms of information, including information and managing. Okay, so reduce the cost and improve energy efficiency in residential buildings. So in that way, we address the need for these most suitable construction processes, I think, and actually we will see afterwards, the processes is the key for the cost reduction and increase the energy efficiency of the building. okay, by the integration of the whole value chain at the end, a digital twin environment should be able to link all the value chain across the life cycle, okay? So from design to the end of life, and the interoperability is key, okay? So how we can create this interoperable and flexible ICT platform, okay? So it will integrate all the data, all the relevant data. At the end, probably all the data is not necessary, but all the relevant data of the real building, that this data will evolve with the real building, okay, with a real asset, and therefore we can create this digital twin that will evolve jointly with the real asset. So after, this project is going to end by this year in November. Okay, so what you see here is a simplification of the architecture that has been a lot of back and forth, but at the end we finally agreed to use as the platform as a service, a joint or a partly integrated core platforms, which is our D-Twin platform from IDP, the NIANX portal, and the BTT research platform, which is mostly focusing on IoT. Okay, so at the end, NIANX portal has a huge strength in the structured information. Okay, so we can use it for seeing all the data structures and trying to enrich the information of the data structure. And the D-Twin platform is able to both visualizing the structured data coming from an IFC or a Revit model, but also being able to connect with IoT sensors or SCADA sensors that we may have. And based on these core platforms, we have all this list of tools, different tools that may be focusing on different steps of the life cycle, or can be used for easing, okay, the transition among them. And we were using all those platforms and tools, okay, all this ecosystem, and not only the ecosystem and the integration of the tools, obviously at different levels. Integrating everything is impossible. So at the end, it's trying to look for real use cases that could help, okay, to generate this methodology, okay, that can help to get the best orchestration, okay, to using the platforms and tools in those scenarios, in those pilots, okay, to test them. Here it's a list of the tools, obviously trying to reduce all what we have been doing in the last 4 years with a 12 million euros project. It's tough, okay, so I'm just trying to list them. Okay, the tools, okay, that we have. As you could see, some are from the, like, it could be from the ISD, okay, to have a first draft of the cost that you may have and how you can optimize both for water systems or for energy systems, but others are quite advanced in the operation, like it might be the HTM, the human thermal model from BTT, that can help to not only to get synthetic personas, okay, during the designing phase, okay, to get a best simulation of what could be happening and what those synthetic personas can feel in terms of thermal comfort, okay, because obviously it changes completely if a person, a 20 years person of 2 meters, okay, a high of an old lady of 17 with 50 kilograms, okay, so the thermal comfort and feelings is completely different. So in terms of life life cycle cost assessment, we have different tools. Okay, energy management systems more devoted to the operation phase, and we also have other tools that are more integrated inside the platform, like might be the blockchain tendering that is helping across the whole process to get timestamps, for example, of the information that has been created and has been incorporated into the repository. As I mentioned, this is, for example, one of a screenshot of the landing page, okay, of the Sphere platform, okay, where we have located in the map the 4 different pilots. One pilot is in Netherlands, is a new residential house. In Italy, we have an apartments and office new building. Okay, at the end, renovation. Finally, we had some. I suppose that as it's usual. Okay, pilots is an evolving thing. Okay, so we need to change some pilots. Okay, but at the end, we had a renovation case in Finland. Okay, which is a factories and office coming from a building of the 1960s. Okay, and in Luxembourg we have a really interesting building prefabricated in timber. Okay, that help us also to test that in use cases coming from industrial construction. In terms of the business model, we have been evolving a lot of since we are closer to the end. So we have been trying to, we are studying actually, okay, what could be the future revenue streams or cost structure in terms of the ecosystem. Okay, what could be not only obviously the value proposition, but the customer relationships among us. Okay, as key partners, I think it's important to mention here that we created in 2020. It was not easy because it was the first high peak of the COVID situation. Okay, so we were all Europe in lock-in, but we managed somehow to create the Building Digital Twin Association. Okay, the BDTA, where all this open knowledge that we have been created and that should be underpinning, okay, all those business model was set. Okay, and right now is evolving, and I think it's important to mention that we are going to celebrate our second International Congress in Barcelona in a month's time. Okay, about lessons learned. I wanted not to be too extensive, but I think it's important. First, probably people more aware of somewhere development. It's something that we already knew. Okay, but developing the pilot testing activities and plan was really hard. Okay, we identified several obstacles and issues to be addressed, so the real people could be really testing our tools. Okay, and actually this is something that we are still fighting, but I think it's truly a part of the testing process. Okay, how we can do not only alpha testing but also this beta testing with the real people. In terms of the types of buildings, we discovered that obviously that the administrative offices, like the offices buildings, are much more predictable. Okay, but at the end, even in this latest case, the only way to close the gap, okay, is obviously having a simulation across the whole life cycle. Okay, that this simulation will be linked, okay, with the IoT or the monitoring data that you are going to have from these smart buildings. At the end, if you don't have a smart building, it's going to be really difficult, okay, to have a proper simulation, okay, for this building and for the next ones. Okay, but at the end, with this, you are only going to have one part. Okay, so getting this digital twin evolving the information, so the simulation could be set on updated data. Okay, but it's needed to have the information coming from weather and personas. Okay, so firstly with synthetic information, okay, afterwards with information coming from the real business. obviously, this raises huge, big privacy and ethic concerns. Okay, and actually, one of the things inside of the Building Digital Twin Association we are going to set is a working group devoted just for those privacy and ethic concerns on how we can find a standardized way to approach them. And finally, one of the most important lessons also was how to capture the data automatically. Actually, it was from the beginning, okay, how we can capture data automatically in the platform. Obviously, with information coming from monitoring, it could be much easier. The structured data is not easy. I think people with experience in BIM and construction in construction phase know that tends to diverge and the gap increases, okay, with each step inside of the construction site. But at the end, the structured data could be done, okay. But there is a lot of other data that needs to keep be stored, okay, in the platform, in the environment. So at the end, we discovered that it's impossible to automatize everything, okay. So at the end, it's more important to have a right framework of definitions of roles, okay, and processes to keep this on track, okay, with a short lash of deviations on this information. And this we try to put in a really summarized way inside of the first white paper that was released by the Building Digital Twin Association and that you could find in the website. So that's all. Thank you.
Thank you, Edward. The project EDICE will now be presented by Michał Pomianowski from Aalborg University.
Yes, good afternoon. I hope you can hear me well. Thank you for the invitation. I will present EDICE, which I coordinate on behalf of the consortium that consists of, in total, 10 partners that are located from the south of Europe till the north of part of the Europe. So a brief introduction what this presentation will be about. Well, I will focus on some main key aspects of the project, the objective, our approach, some of the achievements and some of the results, and at the end I will share with you the lesson learned. Unfortunately, in the very short time, I will not be able to share with you some of the side activities that we have in the project that maybe are also very interesting, but unfortunately the time will not allow me for that. And I will also not be able to go very in detail into the aspects of our developments and our work. What I want to highlight here is that the project started in September 2020 and will end in end of August 2023. So we are more in the just passing the middle of the project rather than maybe finishing the project. So we have still some months of work to do. Okay. So sorry. About the project objectives. Well, the project is generally about the scouting and proposing what could be done to shift from static steady state assessment of the building and the certification of the building towards a dynamic assessment and certification of the building. And the first of the objective is to develop and deliver the methodology for dynamic certification. And in here we work both with modeling part, so what is the level of the complexity, what could be simplified in the modeling environment in order to not produce too complex models while still provide credible results of our modeling. And the second pillar of our work is to support our assessment of the building with feasible monitoring. Then the second objective is to develop the integration framework. And why it is very important here is simply because when moving from static approach and static modeling assessment of the building towards dynamic assessment, the process grows in complexity. Here we work with more input parameters. We suddenly work with dynamic weather boundary condition. We can produce many more outputs from the model, and we have our models that basically are not performed just once, but can be updated and can be run almost in real time. So the complexity grows here, and we need an integration framework in order to facilitate this entire process so that it is not too complex and at the end not bringing additional burden to the building owner in form of a very high bill for the service. Then the third objective is about providing the clear feedback as a result of our investigation. So here we work with several key performance indicators across energy, indoor climate, and free running operation of the building. And we also work with the proposal for more credible renovation roadmaps for the building. The fourth objective is about proposing operational savings. In here, we are able to work more dynamically and more on the actual performance of the building. So we can propose some of the passive solutions to increase the efficiency of the building operation. We can propose acceleration of the free operation of the building by suggesting the deactivation of mechanical system to operate. And we can also analyze the building from the perspective of the performance gap, which is simply the gap between what we are modeling the building should behave and what is its actual performance. And then the last objective is, of course, to demonstrate our developments in the real conditions, so in the number of the demonstration buildings that we have. And we have buildings from north of climate of Europe to the south parts of Europe. I think Cyprus is the most south located building. Okay, no, sorry. Okay, our solution or key results, they align, of course, with the project objectives. One of the key developments that we have in our consortium is the development of the Python-driven simulation tool, which is called PreDice, and it supports the model, the simulation of our models. Here we have several input parameters that are automated. We have a weather compiler. We have a scenario of use that can be integrated, and we have also several outcome parameters that are automatically generated, where we can aggregate the parameters. We can analyze the results with respect to identify key performance indicators, and we shall be also able to generate informative plots from all of the data that we generate. The second result is the generation of the DEPC protocol, which is describing our methodology. That is one of the things. And the second thing is simply giving a map of the results that we produce for the asset operation of the building and for the operational assessment of the building. The third result is our middleware platform. This is our heart of the project, where we can collect and store the data. We can automatize execution of the simulation. We can store the weather condition that we import into our models. We can generate the feedback and information to the users in form of some graphical interfaces. The fourth result is about renovation roadmaps and analysis of the performance gap. This performance gap we are expecting to do in the next months. We are not ready with that part. And just to sum up, what is it about? It's about reliable assessment of buildings with respect to comfort and energy, and analyzing the performance gap for the buildings. Okay, now our approach. The simple logic of the approach is presented on the left side of this slide. You can see we have our dynamic simulation models that are fed with the information about the building envelope, mechanical systems, and some other parameters that are necessary to implement in the model. Then we have another input that is about our use of operation of the building. This can be measured. This can be also some standard parameters of use. And then on top of that, we have also our weather condition that could be either real measured weather condition, or it could be a standard weather condition. From there, we have our theoretical performance, which is simulated, and this we can compare to the actual performance of the building that is measured by the sensors that we install in the building. The comparison between these two is called performance gap, and we are working on decreasing this performance gap in order to have a better models of the building, to be able to propose better solution for the improvement of the operation. In general, this logic, if we transfer into the assessment types of EPCs that we have at the moment, then we will see that our approach is addressing more the actual assessment of the building and operational of the building, rather than the standard operation of the building. So this is our goal and this is our aim. And now just some of the examples of work. If you develop the models, you normally your result is as good as your model that you develop, and as good as the assumptions you make about the model. So you can see two ways of developing the model. One on the left side would be more standard approach, where you have standard assumptions for temperature set points, for ventilation, for operation of use and loads. And on the right side, you could have another approach where you are more relying about the diagnosis of the building and, let's say, the actual operation of the building, where you would insert your measured weather condition, not the standard one, where you could implement your set points that are based on measurements, where you can modify ventilation rate to more actual air change rates, and where you can upload the instead of standard actual operation of use of the building. And from here you have results, energy, indoor climate parameters that you can start to compare. What are the consequences of your assumptions? And of course, both of the simulation results you could compare with the measurements. And this is what our pre-dice tool is supporting, where you can see we create our model. On the left side, we have IDF model that still we have to do manually, but there are several parameters that you can automate. So there is a JSON files and CSV files and EPV files with weather condition that are controlled by the pre-dice Python script that can automatize this process. And then the same pre-dice tool would generate the KPIs for the standard, for the actual condition, and at the same time take into account the monitor condition that we measure in the building, and do the comparison and the plotting of the results. To be less abstract and more accurate, here are some of the KPIs that we have identified. I will not go into detail here, but these are grouped into families of KPIs. Some of the KPIs are reflecting on the energy behavior of the building. Another KPI family would be about indoor environment. and another family would be about free running operation of the building, so the activation of the mechanical systems in the building. Now, very shortly, sharing some of the results just to give you the impression of what we are doing. These are some of the results from one of the case building that we have, where you can see the heating energy use over the time. The results are plotted hourly, so we have a dynamic simulations, several models of complexity that we investigated, and then we model this building with standard weather data, standard set points, and standard schedule of use for the loads. And we can compare our modeling approaches, different ones, with the measurement which are given with by the yellow bold curve, and you can see that, well, if you use this standard assessment approach for the assumption for the model, well, we are not that good in assessing the for example heating energy use for the building. However, if now we change some of the assumptions for the model and we try to implement more actual condition in the building, we would be probably much better in simulating. These simulate results would be closer to the real measurements in the building. So now we have replaced real weather, the weather condition with real weather condition. We have changed the set point for heating based on the measurements in the building, and we are not yet we have not yet implemented the actual use of the building and loads, but this is something that we hope will come, and we can see that actually we are becoming better and better in assessing the energy performance for heating, at least here for the building.
Michael, sorry
Yes.
to interrupt. Can I ask you to wrap up in 1 or 2 minutes, please?
Yes.
Thank you.
Actually, this is the last slide. So the lesson learned, to finalize, yes. All activities related to monitoring and installation of the sensors in the building were more demanding than anticipated. So this is quite a challenging part of the project. We also observed that moving EPCs from static tool to dynamic tools lead to actually disaggregated KPIs. We are afraid to provide a label as a one number that could maybe confuse, because this might be not the same as static tool would give you, and would not be composed of the same energies. Then the third lesson learned is about the simplification of the model. Seems reasonable and reliable, but more with respect to the energy calculation than for comfort calculation and evaluation. And use of smart meters seems to be a very valuable part for assessing the heating demand of the building, but here we have to be careful about the decimals and what kind of data we have from smart meters, how accurate these are, and to how many decimals this is. And then the last lesson learned is that it seems that scripting and this execution of the programming execution of the models seems to facilitate the process and might have a potential for shifting from static to dynamic models. Okay, thank you, and sorry for if I took too much time.
No, that's fine. Thank you so much. Our next speaker is Maaike van Jacob from Wuppertal Institute, presenting the Quality EPC project, which is also working on enhanced energy performance certificates. We cannot hear you. Maaike, maybe you're on mute.
Sorry.
That's better.
Yeah. Thank you very much. My name is Maaike van Jacob from Wuppertal Institute in Germany, and I will present the Quality EPC project, which is on high quality energy performance assessment and certification in Europe, accelerating deep energy renovation. Well, I guess we're one of the older projects in this round, as we have already started in September 2019, but we took the opportunity to extend the project up to the beginning of next year. We have project partners from Belgium, Bulgaria, Germany, Greece, Hungary, Latvia, Sweden, and Spain. That was too quick. Yes, our project objectives. Well, the motivation behind the project was that the EPCs are important for market transparency, but there are some number of weaknesses, like the reliability of energy performance data and the label class, the very difference between member states in certification procedures and in the EPC design, the quality of the renovation recommendations, the cost and the cost effectiveness of the EPCs, and the market compliance with the regulations on advertisements and EPC presentation. Therefore, our project wants to enhance the EPC assessment certification verification regarding the quality and the cross-EU convergence of EPC schemes, including the building assessment and EPC issuance, design, verification, and use. And also, we want to enhance the link between EPCs and deep renovation. Okay. Yeah, so in the beginning of the project, we have identified several expert workshops our 7 development priorities for enhancing the EPC systems. And these are improving the recommendations for renovation provided on the EPCs towards deep energy renovation. Then an online tool for comparing EPC recommendations to deep energy renovation recommendations. To create some deep renovation network platforms, to regular mandatory EPC assessment training. We want to enhance the user friendliness of the EPC. Then voluntary and mandatory advertising guidelines for EPCs, and the improvement of compliance with the mandatory use of EPCs in real estate advertisements. All these issues are very, very different in all the EU member states. And so we tried to develop some common concepts in our Quality EPC white paper. And some of these concepts have already been implemented or are in the phase of implementation. For example, for some of our project member states, we have implemented a deep renovation network platform, which is called Qual Renovate. And in the picture above, you see our enhanced EPC form, which we have tested in quite some countries and buildings. So, yes. Our approach. In the beginning of the project, we started with the analysis of existing EPC schemes, good practices, shortcomings, and priorities for improvements. And yeah, there we really saw how different all these systems in the EU are. And after this analysis, we developed some concrete proposals and tools for the EPC assessment, and also for certification and verification, as well as also, these deep renovation network platforms. And all of these developments we do in intensive dialogue with involving all the major stakeholders on the EU level, but definitely also on the national level. Then we did some testing, especially of the enhanced EPC form in 98 pilot buildings in all our countries. Based on this, we are developing or have developed a roadmap for the adaptation to the country needs and the implementation consensus elements, as well as we are now developing a roadmap for further dialogue, which is of major importance. And our final result will be a strategy, a sustainability strategy and conclusive policy recommendations for regional, national and transnational dialogue, and also for transfer to the national levels. No. Yes, here. As our project still has a while to go, I won't bother you with some project details, but we'll come up with some more general lessons learned. Now, the first one is that changes need time, but they are possible. And what you also need is a window of opportunity. And in our Quality EPC project, the changes in the EPC systems often require legal changes. which are not so easy to make. So the EPBD recast hopefully is one of these windows of opportunity in which we can influence the EPBD itself, but also the implementation in the member states, which will, definitely follow after the EPBD will be implemented. And another lesson learned is that projects like QualiPC and your projects are very important for reaching EU convergence, as especially the EPC systems are so different in each of the member states, but we are all heading for the same target, meaning deep renovation and carbon reduction in buildings. It is necessary to improve the convergence and to talk about it and to discuss solutions that are acceptable for all member states. Well, that was all from my side for the moment. Thank you very much.
Thank you so much, Maike. And now Sonia Alvarez-Diaz from Cartif will present BIM Speed.
Hello, thank you. Hi to everyone. I'm Sonia Alvarez-Diaz, and I'm an architect, and I research in the Cartif Technology Center in Spain. I'm going to tell you about the BIM Speed project, which name is the Harmonized Building Information Speedway for Energy Efficiency Renovation project. And the project is going to finish this year in October, and it's focusing the energy savings on site and comfort, health and well-being, and information to occupants. So the project objectives are to enable all the stakeholders to adopt BIM to reduce the time of the renovation project by 30%, providing affordable BIM cloud platform, tools and standardized procedures, creating and implementing renovation solutions with guarantee energy performance, and demonstration of these technologies and methods and tools, and inserting different residential buildings, which occupy all of the types of the housing that exist in Europe. Sorry, okay. So the solution of the project is to develop and validate interoperable BIM tools to support all actors involved in the renovation market: designers, engineers, construction firms, stakeholders, building owners, local authorities, and inhabitants. And its other is to define and standardize BIM-based procedures for acquiring and interpreting data from the existing buildings, as BIM modeling, building and energy modeling, and performance analysis. Here you can see the BIM speed concept. When we try to obtain a platform to connect all the renovation phases and all the tools involved in this renovation phases. And for that, a cloud-based BIM platform that is open, affordable, and user-friendly is one of our objectives of solutions. And a set of interoperable BIM tools, existing and new ones, all connected through the BIM cloud platform, and validate and standardize a procedure for BIM-based activities throughout the whole renovation process. The procedures defined before, we want to validate this procedure. And our approach that we have been following the BIM Speed project has been provided a BIM platform as an open ecosystem around renovation project, where software developers can integrate their own applications or link to other ecosystem or BIM platform, and to development of BIM connector and ETLs to solve interoperability uses between the BIM Speed platform and the BIM tools. And here you can see our approach, that is that the BIM Speed platform, where the project and information and data of the project with different standards are included. We propose to generate a set of layers. The first one is the BIM connectors to connect to the tools with the platform, and propose different solution of the ETLs, not for all the tools, because sometimes it's not needed to transfer or extract or load data, but sometimes it's needed. So it depends on the tools and the requirements of the tools. And in the middle, we propose to generate the checkers, some checkers, to check that the requirements of the tools are okay, or to check the requirements of the data included in the BNSP platform. And other approach is to develop a set of use cases with different procedures applied in the building renovation project. So in the project, we are obtaining some achievements. That is the BNSP platform as an open ecosystem. And here you can see a sample of some of the tools developed in the project. There are more. And focus on all the phases of the bicycle project. So one of the phases is the system building data collection, the renovation design phase, the performance analysis phase, the execution of renovation work phase, and the occupation and maintenance. In this case, here is the BNSP platform connected through APIs to the interoperability framework, to the BIM connectors and ETLs, and connected that with the tools. Later, I'm going to show you two examples. One of the 3DAS tool connected only with a BIM connector to the platform, and the acoustic comfort KPI tool connected to the platform using a ETL developed in the project and a BIM connector. And some tools are only for one phase of the project, but other tools, for example, like the 3DAS tool, that is the objective is to transform the point clouds to be model, can be used in different phases, and like other tools that can be used in different phases of the life cycle construction process. And I'm going to show you here some relevant publications of the project. One of them is the use of machine learning methods for the improvement of the renovation building project, using as BIM models. If you want to know more, you can see the publication. And other is to show the Renoins. This is an ontology generated in the project to support renovation project planning and renovation product installation. In the project, we are developing different ontologies, and this is one of them. And other publication is BNSP Innovators API. APP, sorry, and you can see the information of this tool in this publication. There are more publications, but these three are more or less the relevant publication of the project. I don't know what happened. Okay. I'm not sure if I can continue. Okay, yeah. So one of the demonstration is the 3DAS tool, as I mentioned to you before, that only is needed with the platform a BIM connector. And in this case, this tool is really different of the other tools because it's a plugin for Revit software. So you only need to connect to the platform to download the plugin, and later you have to install the plugin in your software. But I want to show you the process in the case. In this case, you have to access to the BNSP platform and with the format available for the tool, that in this case is PTS, you can launch the service. This is a web service, and launch the web service of the 3DAS tool. And here you can download the plugin, and later you have to install in your computer the plugin. And this is the result of the use of this tool, and to transform point cloud in BIM elements in the building. This is one of the demonstration. The other demonstration is the acoustic comfort KPI, and this tool has been developed by UniVPN. And in Cartif, we are developing the ETL to transform the data, because this tool needs some input, and we obtain the input using the models, the demonstration buildings in IFC format. So the first step is to connect to the platform. The server is connected to in the platform, so you have to launch the service using the IFC format. And later here this is the bin connector, the web service of the IFC for acoustic parser, and the IFC is loaded automatically in the web, and you have to launch the service. And here the tool is working, the ETL is working to parse the data between the IFC and the JSON file that is needed in the acoustic tool. And the last step is the tool obtain the results using the information included of the ISC and might be in the JSON file. And in this case, that the result was that is not requirement. The building is okay, so you don't need to modify the envelope for the acoustic part. And later, this output is come back to the platform using the bin connector. So the information of the JSON file is uploaded automatically in the platform again. So this is one of the example of the two different connectors using bin connector directly only in the 3DAX tool, and using the bin connector and an ETL for using the acoustic comfort tool. So the lesson learned in the project, and the use of the BIM methodology in the AEC sector has proven to be useful for all the actors involved in the project, and not only for the new buildings, but also for renovation of existing buildings. And the use of machine learning methods is in combination with the BIM models improves the design of the renovation project. Defining different approach to solve the same problem is useful to cover all the existing casuistries. For example, in the project, we are developing three different approach to the process bin-to-bin process. So you can select one do you want to use because it's better for you or not. And the last lesson learned is to development of the ETLs can facilitate interoperability between bin tools and platform. So, sorry. And some recommendations here are it is important to involve those responsible for the demos from the beginning of the project. It's important to define as soon as possible the level of the development and the level of information of the BIM models. Also establishing the common nomenclature to be used in the project. If tools are developed, try to define as soon as possible when the tools will be available for testing with demos, and in which demos each of them is to be used. This is more or less related to the comment that Edward mentioned before in the project sphere. And the last recommendation is it is important to define possible connection of tools for the different workflows between the renovation phases. And that's all from my side. Thank you.
Thank you very much, Sonia. And thank you all for those very interesting presentations. And let's now give the floor to projects that recently started. And we'll begin with Beyond, presented by John Avramidis from UBTech.
Thank you very much. Let me try. Okay. This is my name is John Avramidis. I am with UBTech, which is a Greek software powerhouse company. So the Beyond project started at late 20 and will end at late 23. So as we will see later on in the next slides, our findings could have an application in several areas, as you can see on the right of the slide. And another comment here is that several companies or institutions across Europe having to do with energy domain are participating in this project. Could you change? Okay, great. So let me start with the context of these projects. As we all know, big cities don't only consume energy, but at the same time, they produce a vast amount of data since new technologies are coming in, and buildings and offices as well are becoming, let's say, smarter. So emerges the question, If this data availability can lead energy players to exploit a new business model by interacting with buildings and sharing their data. So also there is a question, can we, through this data, except beyond creating a new business model, expand our cities in a better way, facilitating investments in a more efficient way, or saving more energy. So we believe that we can do this through exploiting energy data. So that's why we started actually this project. Next slide. So I'd like to bring here also some trends, and we group these trends in 3 areas. First, the energy domain. We see that we have renewable energy sources more and more often. We have also efficiency programs and distributed energy sources, and new legislation ruling this domain. On the technology side, we have new technologies like big data, we have IoT devices, smart metering that are already transforming related business model. And on the business side, we are seeing investments based in innovation, as I told earlier, like big data analytics, that are becoming a trend not only for internal optimization, but also in a wider aspect. Next slide. Let's go to what Beyond aspires to do. So we want to build a novel, secure, and transparent platform that introduce buildings as data owners and providers, and this will have the opportunity to upload their data, enhance data quality, and define tailor-made rules related but not limited to confidentiality, privacy issues, and access control. So this way, this data will be made available to consumers like retailers, aggregators, network operators, and so on and so forth. And this will have the ability to search upon this data in the platform that we are going to build, get samples, for example, to assess their usability, and get involved in a negotiation to establish contracts upon which the data will be shared among them. Next slide. Okay, now let's see our technology facilitators. Let me explain you here. So in Beyond, we are developing and we are going to use facilitators like state-of-the-art actual technologies, and we are mainly focusing on 2 main aspects of performance and establishing a robust data management processes so as to allow data owners to effortlessly upload and manage their data on the platform, as well as realizing analytics and interoperability services. Next slide. Another area we are also paying great attention is data sovereignty. So in this end, we are using security tools like anonymization, encryption, and blockchain mechanisms, among many others, but you can see this slide, so as to enhance security and communication between different stakeholders. Next slides. So, based on these technologies, it's obvious that we are at beyond. We are aiming to urge cities and other energy actors to get involved in data sharing, transaction framework, to acquire as much as possible data stemming from buildings and get access to analytic tools. This way, we believe that they could forecast the anticipated performance of buildings in the short, medium, and long term in terms of energy demand and energy generation and flexibility. So all actors involved in this data exchange, as we can see in this figure, can further propagate the knowledge acquired through this platform to be used, for example, in future plans like the extension of the city or investments on city infrastructures or networks based on evidence coming for real buildings so as to make these investments and the future plans more accurate and more efficient, both in energy terms and economic terms. Next slide. So, to develop this data exchange framework and bring it to life, we are going to evaluate it on its full extent of action in realistic setups in 4 European countries, covering all types of energy actors that you saw in my previous slide, in Greece, Spain, Finland, and Serbia. To close this presentation and as an open invitation to anyone related to this landscape of actors, I'd like to invite you to join the Beyond Vision through the Beyond Living Labs. This is a concept that we think of you like a value co-creator. You are taking part of the development of Beyond tools and platform, actually, through reviewing our findings and providing your feedback or our developments. And through your participation, you will have the opportunity to have your hands on the Beyond prototype, and maybe you can also use a future, let's say, commercial version of this platform on favorable terms, if all goes well. So please visit our website, and if you are interested in participating in the Beyond Living Labs, please come in touch with me and with the rest of the Beyond partners. Thank you very much for your attention.
Thanks, John, for this kind invitation. And our final speaker is Inger Andresen from the Norwegian University of Science and Technology, presenting the ARV project.
Thank you very much. As was said, I am Inger Andresen. I'm from the Norwegian University of Technology, and I'm going to present our new project within the Green Deal, which is called ARV, which is actually a Norwegian word. It's meaning legacy or heritage. So it hints that we are focusing on circularity. So our more long name is Climate Positive Circular Communities. We started just this year in January, and we are going to have a 4-year project until 2025. And we have about 20 we have 35 partners from 8 different countries, and we received a funding of 20 million euros for this period. So our overall objective is to boost the building renovation rate and to enable a rapid and wide-scale deployment of these climate-positive circular communities around Europe. And through this, we want to facilitate a fast market uptake and cost-efficient replication of the concept, and thus, through this, significantly contribute to the full decarbonization of Europe by 2050. And in the figure to the right here, you can see our more specific goals. We have goals with respect to new buildings on the top green part, and specific goals with respect to renovation. So we have both new buildings and renovation in our project. And we have these 7 main KPIs and criteria that you can see here, but we also have other criteria in addition to this that we will address in the project. As to the solution and the key results that we want to achieve, this is sort of tried to summarize in this a little bit complex figure. But on the left here, you can see the different stakeholders. We address all the stakeholders along the value chain from planning to implementation and use of these communities, in addition to the more overall stakeholders such as financing institutions and so on. And in the core of our main results will evolve around 6 demonstration projects that you can see in the circle in the middle. They are located from Oslo in the north to Palma de Mallorca in the south. And in these innovation projects, we will find more than 50 innovations within all of these demonstration projects. And in the top to the right, you can see the different thematic topics that these innovations will be within. So they are different types. They are ranging from planning frameworks to solutions within community engagement, environment and well-being, to sustainable building design and redesign, to resource-efficient manufacturing and construction workflows, focusing on industrialization and prefabrication. We also have, of course, integration of renewable and storage systems, and we focus on efficient operation and flexibility to enhance the integration with the communities to the larger community energy systems. During this period, we are going to evaluate and monitor these 6 demonstration projects within the 4-year period. And we are then going to suggest business model, financial instruments, and policy measures, and of course, going to exploitation. And all of these are based on 3 main concepts that will be integrated in all these thematics areas and innovation. And you can see them on the waves on the bottom. They are integration, which means integration between the energy systems, the buildings, and the users. We are, as I said, focused on circularity, which is not only on energy system, but it's also on the materials use and the CO2 emissions. And then we would like to do it in as simple as possible way, both for the planners, for the designers, for the operators, and for the users of the buildings. So this is sort of the basic concepts that we are trying to achieve. And as I mentioned, we are focusing on the 6 demonstration projects. They are all urban transformation projects, quite large ones, where we regenerate existing areas and also build new buildings. We are covering the different climates, as you can see, and we also have different building types, mostly residential, but also some public and educational buildings and healthcare buildings. And there's mostly renovation actions, but we also have some minor new construction, 25,000 new construction and 130,000 square meters of renovation. So that was all I had. Thank you very much.
Thank you very much, Inger, and thank you again to all our panelists. Unfortunately, we won't have much time for our Q&A session. I think we only have 5 minutes left, so I guess most of our participants will have to leave soon. But if you have a burning question, and I invite you to enter it in the chat session, so we can try to answer it swiftly. But otherwise, I invite all our participants to contact our panelists to learn more on their project. And I also invite you to join our task forces to share questions, lessons learned, and good practices related to smart building topics. I put in the chat the registration link to our next workshop. It's next week. So we'll have some brainstorming together if you want to join us. So yeah, I don't think we have any questions. So in that case, let me thank again all our panelists. Many thanks to our participants. As mentioned at the start of the webinar, the recording and the whole presentation will be available on BuildUp website. And if you haven't done so already, please register to our Smart Building Innovation community on Smart Build for EU website. We should have again a similar event later this year. So if that would be of interest for your project or initiatives, please feel free to get in touch. And by then, let me wish you a great afternoon. Thank you.
Thank you. Bye.
Thank you very much.
Thank you very much. Have a nice evening.
Thank you very much.